Hello, my name is Joshua Gavi. I welcome you to Water. Our lesson objectives will include the structure of water, hydrogen bonding, thermal properties, water versus methane, cohesive properties, solvent properties, and significance of water. You are welcome. Water structure. Water is made up of two hydrogen atoms covalently bonded to an oxygen atom. Water is made up of two hydrogen atoms which are covalently bonded to oxygen atom. Now when we look at our water structure here, we have the oxygen atom here, and this oxygen atom is bonded to two hydrogen atoms. So that is what we are saying, that water is made up of two hydrogen atoms covalently bonded to an oxygen atom. The two of them, they have a covalent bond joining to the oxygen atom. And those bonds are covalent bonds. Oxygen has a high electronegativity and attracts the shared electron more strongly. The oxygen is the one which has a high electronegativity and it attracts the shared electrons more strongly. Now let us look at our water molecule here. When you look at this water molecule here, up here we have the oxygen. This is our oxygen. And the oxygen has a high electronegativity. Why? Because here up we have two lone pairs. There is a lone pair here and there is another lone pair here. Now we have formed a bond between hydrogen and oxygen here and hydrogen and oxygen here. Now the electron which we have, which is black here, this electron here, the black one, that one is provided by oxygen. And this other black oxygen here is also provided by oxygen. Now this one, the red electron here, is provided by this hydrogen. And this electron here is provided by this hydrogen. But when you look at these two electrons, they spend much of their time where oxygen is. That's where they spend much of their time. They are spending much of their time towards oxygen, not towards hydrogen. They have moved away from hydrogen. So that one, because most of the electrons are situated where oxygen is going to develop a partial negative charge, and hydrogen will develop a partially positive charge. And therefore, that means that there is a high electronegativity towards oxygen. So the shared electron will spend much of their time towards oxygen and far away from hydrogen. So that's what creates the partial positive on the hydrogen and partial negative on the electron, on the oxygen, because most of the electrons spend most of their time there. This results in electrons orbiting closer to the oxygen atom, creating a polarity. Because of the high electronegativity, we have seen that most of these electrons, they spend much of their time near oxygen. And because of that, there is going to be a polarity created. So because the electrons are more towards oxygen, it is going to develop a partial negative. And because the electrons have run away from hydrogen, hydrogen will develop a partial positive. So creating what we are calling the polarity. And what is bringing about the polarity is that because the electrons are orbiting closer to the oxygen atom and moving away from the hydrogen atom. So that one results in the creation of a polarity. The unequal electron distribution, results in a permanent dipole. It results in a permanent dipole. Now, a dipole, it is that one where we are having the charges, the polarity. Because the electrons are spending much of their time towards this side of oxygen, so oxygen is going to develop a partial negative, and hydrogen will develop a partial positive. That is what we are calling the permanent dipole, because of unequal distribution of electrons. This one is going to result in a permanent dipole, oxygen being negative and hydrogen being positive. Hydrogen bonding. The dipolarity of water molecule allows it to form polar associations with other charged molecules or polar or ionic. Now we have seen that oxygen has got a dipolarity, whereby the oxygen is partially negative and the two hydrogen are partially positive. So the water molecule has got a dipolarity, and this one makes it easier to form association with other polar solutions or other substances that are charged, the polar and the ionic. Now let us look at our structures here. This one that we are seeing here is a water molecule. The whole of this one is a water molecule. And this one here, this is hydrogen. This one is hydrogen. So here we have hydrogen. Even this one is hydrogen. But in the middle here, we have oxygen. So the oxygen is partially negative, and the hydrogen, they are partially positive. And because of that, the water molecule is dipolar. Now when you look at this other water molecule here, if you look at this other water molecule here, you will find that this oxygen is negative and this hydrogen is positive, and even this hydrogen is positive. So when the water molecules are in solution, they are going to orient themselves in such a way that the positive will face the other molecule which have got a negative. So we shall have a bond which is formed, a partial bond formed between oxygen and this hydrogen. And that bond is what we are calling the hydrogen bond. Why is it like that? It's because oxygen has a partial, hydrogen has a partial positive. It's partially positive. And oxygen is partially negative. So because of those polarities, hydrogen being positive, oxygen being negative, there is a bond which is created. And that bond is what we call the hydrogen bond. Because oxygen being partially negative, hydrogen being partially positive, there is that attraction. And that attraction bond is what we call the hydrogen bond. Hydrogen bond are particularly stronger polar association that form between hydrogen and either fluorine, oxygen, or nitrogen. So here we are saying that the hydrogen bonds, they are stronger polar associations. These are stronger polar associations. For example, oxygen here is partially negative, and hydrogen here is partially positive. So because of those polarity, there is an attraction between the oxygen and then the hydrogen. That attraction is what we are referring to as the hydrogen bond. It occurs between hydrogen and fluorine, or hydrogen and oxygen, or hydrogen and nitrogen. That's where we can find the hydrogen bonds. This is because hydrogen atoms have a weak electronegativity, while fluorine, oxygen, and nitrogen atoms, for them they have a very strong electronegativity. So oxygen here, strong negativity. Hydrogen here, strong positivity. So oxygen here has a very strong electronegativity, and hydrogen has a very small electronegativity, therefore meaning that it is partially positive. Oxygen being with a strong electronegativity, it is partially negative. And because of those polarities which are created, then we are going to create a bond of attraction between the oxygen and the hydrogen. And that bond which is formed is what we are referring to as the hydrogen bond. Water molecules are polar. The water molecules are polar, and a hydrogen bond forms between them. Because they are polar, they form hydrogen between them. What are we saying? Oxygen on this water molecule is partially negative. Hydrogen on this water molecule is partially positive. And because the water molecules are polar, there is a creation of the hydrogen bond. The hydrogen bond is formed between the oxygen and the hydrogen of another water molecule. Water molecules will collectively form hydrogen bonds. That is hydrogen and the oxygen. So for them, they form what we are calling the hydrogen bonds. And those hydrogen bonds are formed between the hydrogen and then also the oxygen. They are the ones that are going to form the hydrogen bonds between oxygen and hydrogen. Properties of water. Intermolecular bonding between water molecule gives water a distinctive property. So we are saying the intermolecular bonding. Which one is the intermolecular bonding? Those are the hydrogen bondings that are existing between the water molecules. Those ones, they give water a distinctive properties. They give water distinctive properties. One of the properties is the thermal property. Thermal property. Now, water can absorb a significant amount of heat energy before changing its state. So, when we apply heat to water, before it changes from liquid to vapor, it will require you to provide a lot of heat to break those bonds so that the liquid water can turn into vapor. Therefore, that means that water can absorb significant amount of heat energy before it changes its state. This means that if we want water to change to vapor, we have to provide heat. And what is the purpose of that heat? The purpose of that heat is to break the bonds between the water molecules, break the hydrogen bonds. When the hydrogen bonds are broken, now the water molecules are free to disappear. They will evaporate. But you will find that because of the high water has got a lot high heat capacity. To break the bonds, you need a lot of energy. So that one is the thermal property. Another property is the cohesive and adhesive properties. Water sticks to water molecules and charged substances. Now here we are saying that the water molecules can stick on other water molecules. And when water molecules stick on other water molecules, that type of force, we call it cohesion. It's where water molecules attract another water molecules. Or the water molecule can stick to charged substances. They can stick to charged substances. And that force of attraction between water and charged substances is what we call adhesion force of attraction. So that one is a property of water. Another property is the solvent property. Here water dissolves polar stroke ionic substances. So what we are saying is that water can dissolve substances that are polar, substances that create polarity, partial negative, partial positive. Or it can also dissolve ionic substances. Ionic substances, these are substances that have got charges, negative charge and a positive charge. So those substances can dissolve in water. And this makes it an effective transport media. So water can transport polar substances and ionic substances. How? It dissolves them. When they dissolve in water, then they can be transported in water in a solution form. That is the solvent property of water. Thermal property. Let's look at thermal property and we look at coolants. Water has the ability to absorb significant amount of heat before changing its state. Now remember, we are talking about water. We talked about the hydrogen bonds. And those hydrogen bonds gives water the ability to absorb a significant amount of heat before it changes its state. When does it change its state? By changing of the state, it means that the hydrogen bonds have been broken. And those hydrogen bonds, to be broken, you have to use heat energy. So the water will absorb that heat energy in order for it to be broken down, and then it can change into vapor. So water can be used as a coolant. Why? Because it can absorb a lot of heat before it changes its state. Now let us try to look here at a hot skin which produces heat. This hot skin produces heat. And here we have water molecule here on the surface. Now this water molecule can be like sweat. When the skin produces heat, it produces sweat. Sweat comes on the surface. Sweat will come on the surface of the skin. And when the sweat comes on the surface of the skin, as it is occupying the skin surface, the skin which is very hot will start releasing heat, and this heat will start entering the water bubble or water molecule. Now when the heat enters into the water molecule, those water molecules, they need a lot of heat energy to break their bonds. That means that they will absorb a lot of heat from the body. And after absorbing a lot of heat from the body, now the bonds of between the hydrogen bonds between the water molecules is going to be broken. And when the hydrogen bonds are broken, now the water which escape will start escaping as vapor. It will start moving away from water as vapor. Now that vapor which is going, it is taking away the heat from the skin. And here now, our skin will start cooling because heat is causing the water to evaporate, and as water is evaporating, it is going away with the excess heat from the body. And therefore, our body will start to cool. It will start cooling. Now, as water still continues escaping in form of vapor, going away from the skin, it is taking away heat with it. Time is going to reach when the skin has already cooled down, because heat was absorbed by the vapor, and now the skin is cool. This is due to the extensive hydrogen bonding between water molecules. These all need to be broken, that is via heat energy, before a change in state occurs. So when sweat has been released on the surface of the skin, this sweat which is released on the surface of the skin is going to absorb heat from the body. As it absorbs it from the body, it means that now the water temperature is going to start rising. And as the water temperature rises, that water temperature will break the bonds between the water molecules. And what is going to happen? The water molecules will start escaping into the atmosphere as vapor. And as they are escaping into the atmosphere as vapor, they are taking away the heat. So what is going to happen to the body? The body is going to start cooling. And as that one continues on, the body now will cool. And as it is cooling, the water will keep on reducing as most of it is escaping into the atmosphere in form of vapor, and this vapor which is going, it is carrying away the heat which was in the skin, and therefore the skin will end up cooling. So that is how water acts as a coolant. Hot skin will produce sweat. The heat in the skin will cause the water, sweat, to evaporate. And as heat is absorbed by the vapor and the vapor is evaporating, what is going to happen? The skin is going to cool. Thus, water has a high effective coolant. Water is a high effective coolant, making it a principal component of sweat. During hot days, we always sweat. Why? Because sweat contains water, and water is an effective coolant because of its high heat capacity. It requires a lot of heat to break down the hydrogen bonds between the water molecules. And when they are broken up, the water molecules will turn into vapor. And as they are evaporating, they are going away with the heat which was hidden in the body. And the body is going to end up cooling down. Therefore, water is a highly effective coolant. Thermal properties in comparing water versus methane. Now, methane and water have similar structures. That is the size, their weight, and orbital formation, but different in thermal properties due to the ability of water to form hydrogen bonding. Now, when you look at methane and water, you will see that they are similar in their structure in many ways. First, their size is approximately the same. When you look at their weight, is still approximately the same. Even the orbital formation is also similar. But they have different thermal properties. They have different thermal properties. Why? Because they have the same size, the same weight, the same orbital formation. But why is it they have different thermal property? This is due to the ability of water to form hydrogen bonds. Because water can form hydrogen bonds between its molecules, that makes it to have a higher thermal property, meaning that to break those hydrogen bonds, you need a lot of heat energy compared to hydrogen. I mean, compared to methane. Methane does not form hydrogen bonds, and therefore, if you were to heat it, it will disappear very fast compared to water because it has a lower thermal property. Why? Because it does not form hydrogen bonding. Let us compare the thermal properties of water with those of methane, and then we try to see what we are talking about. So when you look at the structure that we want to look at, we have methane, and then we have water. Those are our structures that we want to look at. If you look at their formula, this is CH4, this is H2O, approximately the same, roughly the same size. Now, if you look at their structures, you will see that the hydrogen to hydrogen bond in methane is 109.5 degrees. Whereas for water, it is approximately 104.5, approximately near there, the same. Now, when it comes to freezing, methane freezes at negative 182 degrees Celsius. whereas water freezes at 0 degrees Celsius. Boiling, methane boils at negative 161 degrees Celsius, and hydrogen boils at 100 degrees Celsius. The heat capacity of methane is 2.20 joules per gram per degrees Celsius, whereas that one of water is 4.186 joules per gram per Celsius. When you look at the heat change of fusion, methane is 0.94 kilojoules per mole, whereas water is 6.01 kilojoules per mole. When we come to the heat of vaporization, methane is 8.2 kilojoules per mole. Water is 40.7 kilojoules per mole. So when you look at the thermal property, water has a higher thermal property compared to methane. Cohesive and adhesive properties. Cohesive and adhesive properties. Now, water has the ability to form intermolecular association with other molecules that share common properties. So what we are talking about here is the intermolecular associations. Intermolecular association, and one of the intermolecular association is the formation of hydrogen bond with other molecules. Water molecules and the water molecules, they can form hydrogen bonds. Or it can also form intermolecular association with other molecules which are not water, but those ones, they should be sharing a common property or common properties. So if you have a water molecule here, the force of attraction between a water molecule and a water molecule is what we call cohesion force. Then if you have here your stick or another structure here, water holds on that structure by adhesive force or adhesion force. So that's why we are saying that water has the ability to form intermolecular association with other molecules that share common properties. Cohesion. Water molecules interact with the other water molecules, and therefore they form what we call intermolecular hydrogen bond. So this interaction here between a water molecule and a water molecule is because of the intermolecular hydrogen bonds. And that type of attraction is what we call cohesion. Then we have adhesion. Here water is interacting with the polar or ionic molecules. It is interacting with the polar or ionic molecule. But water cannot interact with nonpolar molecules. It can't interact with nonpolar molecules. So the attraction of the interaction with the polar molecules and the ionic molecules, that interaction is what we call adhesion energy or adhesion attraction force between water and other polar and ionic molecules. Cohesion and adhesion properties, these are important for surface tension and capillarity. For example, water is moving in a tube. It is going to use cohesion forces to attract between water molecules. And it will use adhesion forces to attract the surface of the utensil it is in or the pipe it is passing through. So adhesion and cohesion, They are very important in the surface tension and the capillarity action. Let's talk about the solvent properties. Solvent properties. Water is considered a universal solvent. It can dissolve many substances that contain electronegative atoms, all polar and charged or ionic substances. So we are looking at the solvent properties of water, and because water can dissolve many substances, and those substances are containing electronegative atoms, it is considered to be a universal solvent. It can dissolve polar and charged or ionic substances. Let's look at the structure here of our sodium chloride here. When you look at this sodium chloride, it is made up of sodium ions and chloride ions. So water, what is going to happen? It will come, the water molecule, and surround the chloride ions, and the chloride ions being negatively charged, the water molecules will orient themselves in such a way that the positive hydrogen is the one facing the chlorine ions. And sodium ions being positively charged, the orientation of water will be in such a way that the oxygen molecules are surrounding the sodium ions. And by doing this, you will see that here the hydrogen ion, the sodium ions which are positively charged, and the chloride ions which are negatively charged are separated from each other by the water molecules. And that separation of those ions is going to cause the sodium chloride to dissolve in water. This is because water has formed what we call the hydration shell. So they prevent the chloride ion, which is negatively charged, to be in contact with sodium ion, which is positively charged, by forming a hydration shell around them, and that one causes them to dissolve. So there we say that water is considered as a universal solvent because it can dissolve substances that contain electronegative atoms. Those are charged and polar or ionic substances. This occurs because the polar attraction of large quantities of water molecules can sufficiently weaken the electrostatic forces and results in the dissociation of the atoms. So what we are saying here is that because of the polar attraction of the large quantities of water molecules, it can sufficiently weaken the electrostatic forces and resulting in the dissociation of the atoms. Now, our sodium chloride here, it has an electrostatic force between the chlorine and the sodium ions. But because of the polar attraction in water, this polar attraction of the large volume of water molecules is strong enough to break that electrostatic force between chlorine and sodium. And this one will cause them to dissociate, or it will cause them to separate. It will separate the chloride ion away from the sodium ion, thereby dissolving them. Now let's look at solubility. Substances that freely associate and readily dissolve in water are hydrophilic. We are saying those substances that freely associate, or they readily dissolve in water, they are hydrophilic. Hydrophilic means water-loving. They love water. And they can dissolve in water because they are water-loving. So a substance that freely associates with water or freely dissolves in water is called hydrophilic, meaning that it is water-loving. The hydrophilic substances, they include all the polar, those ones that have got partially negative part and partially positive part, molecules, and the ions like sodium ions, which is sodium plus, or chloride ions, which is Cl minus. All those ones are called polar substance because they readily dissolve in water and they are freely associating with water. Substances that do not freely associate with water, or dissolve in water, those substances are referred to as hydrophobic. They are hydrophobic, meaning that hydrophobic means water hating. They hate water. They can't dissolve in water, so they separate it from water. When you pour them in water, they will not dissolve in water, but they will form a layer. That means that they cannot dissolve in water. So we call them hydrophobic. Those are substances that do not freely associate or dissolve in water. We call them hydrophobic, which means water hating. Hydrophobic substances, these ones include the nonpolar molecules. Nonpolar molecules, for example, we have the fats and oils. If you pour oil on water or fats on water, they cannot dissolve in water because they are water hating. They are hydrophobic. They cannot dissolve in water. So that's why we are saying substances that do not dissolve in water, we refer to them as hydrophobic substances. Transport. Now, transport of material within the blood will depend on their solubility. How materials are transported in blood, it depends on their solubility. Water-soluble substances, these ones include, like for example, sodium chloride. Sodium chloride is ionic. We have glucose. Glucose is polar. And all of these ones are freely transported in blood because they are soluble in water. And being soluble in water, therefore it becomes easier for them to be transported in blood. Then we have amino acids. The amino acids, these ones are transported in an ionized state. The amine group and the carboxyl group are charged. Amine group is charged positively and the carboxyl group is charged negatively. And because of those charges, they can easily dissolve in water and therefore they will be transported in blood in a liquid state or a dissolved state because they are polar substances or they have ionized state. Oxygen is soluble in a low amount. It is soluble in a low amount and therefore generally transported in the red blood cell. So for it, because it is less soluble, or it is soluble in a low amount, it is always transported inside the red blood cells. Water-insoluble substances. The water-soluble substances, for example, the lipids, where we have the cholesterol and then the fats, they are packaged. These ones are packaged with proteins for transport. If we want to transport the lipids, we package them with proteins to form lipoproteins, and then they will be transported as lipoproteins. But they cannot be easily transported as fats or lipids or cholesterol in blood because they are non-soluble. They are insoluble in water. Therefore, those are the modes of transportation of glucose, amino acids, cholesterol, fats, oxygen, and sodium chloride in blood. Other properties. 1. Water is transparent. And being transparent, it means that it allows light to pass through right away to the bottom. And this is important for photosynthesis to occur in aquatic plant. So being that it is transparent as a property of water, this makes the sunlight to pass through the water, and it goes, and then aquatic plants can carry out photosynthesis. Then water is less dense as a solid, that is ice, than a liquid. Water is less dense than, when it is in an ice form, than in a liquid form. How? Now, water adapts a lattice formation due to the formation of hydrogen bonds. And this one results in more space existing between the water molecules. And because the space exists between the water molecules, this is going to make it light. If you look at this solid water, the water molecules are far apart separated because they have formed a lattice. And when they create that one, that means that water is going to become less dense. So water will be less dense in ice compared when it is in liquid water. Why? In a liquid water, the molecules of water are very close to each other. Very, very, very close to each other. They can easily pack themselves. They don't have that lattice which they have when in the ice form. So when they are closely packed together, that makes the liquid water to become more dense compared to the ice water or solid ice. Consequently, ice is lighter than water. So that's why ice floats on water, because it is lighter than water. And this is important for life on Earth. How? Because the floating ice will insulate the water bodies from freezing air. So what happens is that when water freezes, especially during winter, water will start cooling. And as it cools, it will start freezing. And when it freezes, it changes into ice. And because ice is lighter than water, ice will come on the surface and will cover the surface during winter. And when that one happens, it means that now it is insulating the underground water away from the cold or freezing air temperature below 0 degrees Celsius, which is above. That means that now below the water is going to be warm, so that those aquatic organisms can survive during winter. Hello, my friend. Thank you very much for participating in water. And our objectives were structure of water. We have looked at that one. We have looked at the hydrogen bondings. We have looked at the thermal properties, water versus methane. We looked at the cohesive properties, solvent properties, and the significance of water. Thank you. Don't forget to subscribe.